The objective of this video is to form equations to solve energy-related problems when energy and internal store of a substance is transferred by heating due to temperature difference to energy and internal store of another substance. Let us consider the following scenario. A paper cup contains 200 grams of water at 30 degrees Celsius. 40 grams of ice cubes at -10 degrees Celsius are added to the water. Assume that all energy transfers are between the ice and the water only. Determine the final temperature of the water after all the ice has melted. Additionally, we are given the specific heat capacity of ice, specific heat capacity of water and specific latent heat of fusion of water. So how is energy transferred? We know that energy is transferred from higher temperature to lower temperature. That means energy has to be transferred from 30 degrees Celsius water to -10 degrees Celsius ice. We say that the energy in the internal store of water is transferred to the energy in the internal store of ice by heating due to a temperature difference. To put the expression mathematically, the increase in energy in internal store of ice is equal to the decrease in energy in internal store of water. Let us now list down what we do know so far. Under decrease in energy in internal store of water, temperature of water decreases from 30 degrees Celsius to an unknown temperature. Let us call that temperature theta. Under increase in energy in internal store of ice, two things are happening. Firstly, the temperature of ice increases from -10 degrees Celsius to 0 degrees Celsius. Secondly, ice at 0 degrees Celsius melts. Now let us list down all the variables that we do know so far so that we can solve the problem mathematically. Under increase in energy in the internal store of ice, we have the mass of ice, specific heat capacity of ice and the temperature change in ice. Under increase in energy in the internal store of ice during melting, we have the mass of melted ice and specific latent heat of fusion of ice. Note that I use the term melted ice instead of water so that I can differentiate more clearly between the 30 degrees Celsius water and the 0 degrees Celsius water. Under decrease in energy in the internal store of water, we have the mass of water, specific heat capacity of water and the temperature change in water. To solve for the unknown temperature theta, let us focus on the variables and ignore the rest of the information. Increase in energy in the internal store of ice is equal to decrease in energy in internal store of water. We also know that the increase in energy in the internal store of ice is equal to the increase in energy in the internal store of ice from -10 degrees Celsius to 0 degrees Celsius plus the increase in energy in the internal store of ice as it melts. And we also know that the decrease in energy in the internal store of water is equal to the decrease in energy in the internal store of water from 30 degrees Celsius to an unknown temperature theta. Next, substitute the expression with formulae. Increase in energy in internal store of ice is equal to mass of ice times specific heat capacity of ice times change in temperature from -10 degrees Celsius. Increase in energy in the internal store of melted ice is equal to the mass of melted ice times the specific latent heat of fusion. Decrease in energy in the internal store of water is equal to the mass of water times the specific heat capacity of water times change in temperature from 30 degrees Celsius. Substitute all known variables, solve for theta. To summarize, form equation first. Then solve for the unknown.